We're going to wrap up the Unit 3 notes by looking at titration calculations. Now, hopefully you have actually checked out the explanation of what a titration is and all the vocabulary terms with it, because it's super important, and the little demonstration helps. So we'll start with some calculations. Now remember, for titration, it's where the moles, let's just try to think in the realm of an acid-base titration. That's where the moles of the acid equals the moles of the base. That is where we are at the equivalence point, and that is where you can actually do a titration calculation. So that is when things are neutralized, okay? The moles of acid and the moles of base equal each other. They're neutralized. So that's what we're going to look at with example 15. It says, what volume in milliliters of a 2 molar NaOH is needed to neutralize 125 milliliters of a 3 molar H2SO4, according to the equation here. Yeah, you would be able to write this equation, right? Good. So, where we want to start is, a lot of students want to start here because this is the first thing they see. But this is what we're asking for, right? We want to know the volume of NaOH. So we want to know how many milliliters of a 2 molar solution. And we know that there are 125 milliliters of a 3 molar solution. Start with the ones that you really know. You know the milliliters and the molarity here. So start with H2,4. You would not want to start with NaOH. You're going to have a bad time. So start with 125 milliliters of H2SO4, and then you'll convert milliliters into moles of H2SO4. So there are 1,000 milliliters in a liter, right? So take care of that conversion. And then it was a 3 molar solution. Now, since the moles of acid are equal the moles of base, that is when the moles of H2SO4 and the moles of base are in the same correct mole ratios. So that means that there's 1 mole of H2SO4 to every 2 moles of NaOH. Okay, they're in the right ratios right here. You need 2 hydroxides to neutralize 2 hydrogens, right? Because you remember, this is what makes it an acid is an H, and so makes it a base is an OH. Now, then, I will change moles of NaOH and into, moles of NaOH, and since I have the molarity here, I can change it into liters. Actually, I'm going to change it into milliliters because it asks for milliliters. So I'm going to put the 1,000 right here, and then it says it was a 2 molar solution. Now, if you're really a whiz kid, you can do this without a calculator, because that 1,000 and the 1,000 cancel out. The 2 and the 2 cancel out. The 1 doesn't matter. So 125 times 3 is going to be 375. 375 milliliters of NaOH. That's how much is needed to neutralize 125 milliliters of that concentration of sulfuric acid. Cool. Now, let's do example number 16. This one's going to be fun because there's some extra steps involved. What volume of hydrochloric acid with a concentration of 2 molar would have to be added to 25 milliliters of a 0.5 molar sodium carbonate solution to produce a neutral solution of sodium chloride? So let's start with an equation. it asks for what volume of hydrochloric acid would have to be added to sodium carbonate. Knowing the formulas, correct formulas, is critical here, as you can tell. So you need to know that carbonate is a -2 ion, so you need 2 sodiums here. And then it makes sodium chloride, and it will make, this is similar to the last one, where it will make sodium and the chlorine will pair up, and then the hydrogen forms over with the carbonate and should make H2SO4. H2CO3, sorry, H2CO3. But H2CO3 spontaneously decomposes into H2O and CO2. So I will rewrite that. I know that's confusing. HCl plus Na2CO3 will make NaCl plus H2O plus CO2. Okay, I'll go ahead and cross all that out, just so you don't get distracted. Go ahead and balance it. And that's should be good. Now, this is a unknown volume of HCl, and it's 2 molar, right? We want to know the volume of HCl. And then this is 25 milliliters, and that's 0.5 molar. Yes. Okay. So still the same type of thing. We will still start with 25 milliliters and of Na2CO3. Change milliliters into moles. That's 1,000 milliliters in 0.5 molar. And then moles of Na2CO3. And the moles of HCl. It's a 1:2 ratio, or 2:1 ratio. And then moles of HCl into milliliters. Let's go ahead and make it 1,000. It wasn't specific about the volume, but I'd make it 1,000 just so I could cancel out that 1,000. And so, once again, the thousands go away, 2's go away. That's nice. It's 25 times 0.5. It's going to be 12.5. Yeah. Right? Yeah. Okay. Let me know. I'm not feeling confident about that. I don't know why. All right. So that's good. 12.5 milliliters of HCl. Yeah, that looks right. All right. Now for the last one. An acid tablet with a mass of 0.3 grams and containing sodium bicarbonate, baking soda, was added to 25 centimeters cubed of a 0.125 molar hydrochloric acid. After the reaction was complete, the excess hydrochloric acid required 3.5 milliliters of a 0.2 molar NaOH to react the equivalence point in a titration. Calculate the percentage of sodium bicarbonate in the tablet. So there's 2 reactions going on here. 2 reactions. Go ahead and try to find those 2 reactions. See what you can do. Pause the video. You had Na HCO3 and HCl, right? This is this first part. And it made NaCl plus H2O plus CO2, just like the equation before. And it's balanced. Now, then the excess of that, okay? The excess HCl was then titrated with NaOH to make the equivalent, and then that also produced NaCl plus water. Okay? Now we need to calculate the percent of this. So we want to really find the mass of this. That's the true goal. We want to find the grams of NaHCO3. But we really only have data for this second one. So we're going to have to work backwards. How much of this stuff do we have, right? What is the mass of the moles of that, essentially? Okay? So, we're going to find moles of HCl in excess. By doing that, we know that there was 3.5 milliliters and it was 0.2 molar for NaOH. So let's go ahead and take 3.5 milliliters of NaOH and let's change milliliters into moles. And that's 0.200 moles of NaOH. And then we'll change moles of NaOH into moles of HCl. That's a 1-to-1 ratio. Now that will give us 0.0007 moles of HCl. Makes sense. It's a very small amount. Yeah. Now we want to figure out how much was actually initially added, right? So we can subtract how much was left over, how much was initially added. That way we can figure out how much was reacted. How much initially added. So the moles was it was 25. I'm sorry. It was, yeah, I could have just done that. 25 milliliters. And then milliliters to moles using that hydrochloric acid, right? That 0.125 molar hydrochloric acid. And then that will give us 0.003125 moles of HCl. This was in excess. And this is starting. So this is in excess. And this is the starting. So, how much reacted? Well, I'll just take the starting one, 0.003125, this guy, moles of HCl, and I will subtract it. I will subtract it by 0.0007 moles in excess, and then my answer will be 0.002425 moles of HCl reacted. That is how many moles of HCl reacted with the sodium bicarbonate, or NaHCO3. So now I can do that. So how much NaHCO3 reacted with HCl? 0.002425 moles of HCl. I can do moles of HCl to moles of sodium bicarbonate. We can find that mole ratio. That's a 1-to-1 ratio. And then now I can find moles of NaHCO3, grams of NaHCO3. That's the molar mass. So that's 84 grams per mole. So that means that 0.2037 grams of NaHCO3 was reacted. Or present, okay, because not all of the antacid tablet was sodium bicarbonate. You're trying to find the percentage of it, right? How much was in there. So now we know that there is, of the tablet, there was 0.2037 grams, and the whole tablet weighed 0.3 grams. So you have the part divided by the whole, that's your percentage, multiplied by 100 to give you a percentage, and you get 67.9%. Lickety split. That's how you do that question. That's a titration question, and that is a very, very good IB question because it involves a lot of higher order thinking to know how to work backwards and to know that there are two reactions taking place. This subtraction part is the key right here. Knowing that you would need to subtract is it. All right, that's it for titrations. That is it for Unit 3. Congratulations.